Okay, so we'll be solving the question that is, given an array binary tree with factors, question 823, given an array of unique integers r, where integer r at index I is strictly greater than 1. So it says that it's strictly greater than 1, each of the elements present in Ri. So yeah, that's all we know for now. We make a binary using this integer. Uh, okay, we make a binary tree, and each number may be used for any number of times. So if there's like an array given, so an array has 2 comma 3 comma 4 2 comma 4 comma 5, so it can be used any number of times, like 2 used again 4, like 2 4 5, similar to what's given example here, like 4 2 2 array has been formed here. So a tree is formed again with root 4. uh, each non-leaf node value should be equal to non-leaf node value should be equal to product of value of its children. So the non-leaf nodes, like 4 is a non-leaf node, it's because it's root. So okay, we can like give an example here. So instead of writing 3, I'll write a 4 here, and 4 is having children 2 and 2. So 4 is the product of its children, like 2 into 2 becomes 4, right? So that's what it is. Each non-leaf node's value should be equal to product of values of its children. So the product of value of children for 2 into 2 is 4, right? So yeah, that's all we need to do in this. Remember, return the number of binary trees we can make. The answer may be too large, so return the answer with modulo. Yeah, we have to modulo the answer. So like, how can we solve it? So I've explained the question. Now I'm going to explain the question using explain the solution using the visualization process, and we'll code it up. So like, firstly, we'll solve the array. We suppose we have this array 2 4 5 10. I'll just take this example here. I'll just copy the example there, and one by one I'll show you how we can head towards the solution. We will sort the array first. Sort the array. Sort the array. And doing so, we will get what? It's already sorted. It's 2 4 5 and 10. So it's already sorted. And then we'll create a map. We'll create a hash map. Create a hash map and store the value of current, the initial most element, that is this as well. So hm2 will be equals to 1. Alright, now what we are going to do, we are going to loop through 1 2 length minus 1. Alright, the length is 4, so you're going to loop through 3 from 1 2 3. Okay, so 1 2 3, and this will, we will consider these three indexes. So we'll write here 1 2 3. These three indexes we need to go through to go. Alright, and what do we need to do now is, for at each instance, while like our I is equals to 1, because let's just change this color to this. If I equals to 1, we will set count as 1. Alright, we will set count as 1, and then what we want to do, we are going to iterate over all the map elements. So iterate over map. So we are going to iterate over map. So firstly we will check if r of I, the currently r of I is what? 4. 4 is divisible by 2 or not. So we'll check if 4 is divisible by element. If 4 is divisible by 2, indeed yes it is. And again, another thing we have to check is if r of I, if 4 divided by 2 in map. we have to check 4 divided by 2 is present in app. Of course it is present, it is true, so this is true. And so what do we do now? We will increase the count. We'll increase the count by map of this what the second counter was like j. Yeah, j was this one, 4 divided by 2, so we will do j whatever the key was in map, and we are going to multiply it by, what? Map of what we found, r of I divided by j. So this is what, this is j actually, and 2, this is 2 is j, this 2 is j, the already present index key value. So this is j and this is the current r of I, and we are going to multiply this up. So this is 2, right? This is 2 and this is also 2. So 2 into 2 is 4, count was 1, count will become 5. Alright, count will become 5. Great. And then at the end, what we are going to do, we will store in map what we are going to store, map value 4 will be what? 5. Great, value of 4 will be 5. Now similar process we are going to implement for all the rest. Let me just make it a little bit smaller. I equals to 2, which is 5. So similarly we'll take count as 1, we'll take count as 1, we'll iterate j, iterate over map. And what do we have in map? This is our map, and this is 2 is 1, 2 is 1 and 4 is 5. 2 is 1 and 4 is 5. Oh, great. Then we iterate over map and check if the current value, that is what, 5. 5 divided by what did we divide it with? We divided it with, I mean, yeah, like we have to iterate over map, right? So we'll first divide it by 2 and check if 5 divided by 2 in map. So 5 divided by 2 what it is. Actually, it's not modulo, it's divide. So I'm placing 2 here. So 5 divided by 2 is 2. Yeah, 2 is great, 2 is present, but this is not satisfying. Like 5 modulo 2 is not equal to 0. 5 modulo 2 is not true. It's not equal to 0, it's equal to 1. So what do? We just iterate over, we just ignore this and map of count. So 5 will be just 1. We can add 5 as just 1. And yeah, like that's all it was for 5. So we can just ignore 5 and add this, ignore all this, ignore all this. And for 6, this is going to be interesting. Okay, 5, the next element is 10. So I equals to 3. For I equals to 2, we did it. I equals to 1, we did it. Now I equals to 3. 0, 1, 2, 3. We started with 0 and we'll go to 3. Final index. Okay, let's start. Count is 1. Count is 1. Iterating over map. Iterate, or I'll just write it here. Iterate over map. what were the two conditions that we were checking. And first one was if what is the element 10 is 10 divided by 2 equal to 0. Yes, it is. First one is true. And second was that if 10 integer division L, this that is 2 in map. Yes, it is indeed. 5 is there in our map. So what we are going to do, we are going to do count plus. Okay, so map of L value was this one. This is a map of 5. I mean map of 5, and map of 5 is present. So is 1. We'll take the 1 here. This is the 1 here. This, and we just multiply it. And this the second one is we'll check for this if this is in map. So this is 5. We'll check if it is in map. Integer division 2 and 5. Yes, 5 is in map as well. So 1 into 1. So count will increase from, or count will be 1 plus 1, 2. Count will be 2, right? 2. And now again, now we iterate over from 2 to 4. We'll check for 4. So similarly, we'll check for 4 now here. So now this is done here. The count is 2. The count value the count is, I'll write it here and remove whatever we've written here. And now the time is, we go over map key values and put a 4 here and check if these are true or not. So 10 divided by 2, 10 modulo 4 is not, it's not it's not 0, it's actually 2. 0, yeah, it's 2. So this is wrong. We can go over, we can just ignore this. Next is 5. So 10 modulo 5 is 0. Yes, it is. 10 modulo 5 is 0. And 10 uh, 10 divided by the current, that is 5 in map. Yes, 2 is in map. Yes, 2 is in map. Indeed true. It is indeed true. So yeah, what do we do now? So we can just go on and what can we do now is that count equal plus, so count was 2, actually count was 2, and we are going to take the value 1 plus the map of this 2, that is also 1, that is 1, because like we will, the current value of this is 5 is 1, and the value of this is going to be 2. So map of 2 is also 1. We'll multiply this and it becomes 3 now. It becomes 3. Great. So 10 has a value of 3. Okay, 10 has a value of 3. Now what do we do now is that we will go and we will just sum all the values. Take the sum. This is 2 here. This is 2 here. And this was this 10, which we calculated to be 3, because if we go and say it again, like 10 divided by 5, 10 divided by 5 in map. Yes, it is. 10 divided by 5, 10 modulo 5 was actually 0, because 10 is a multiple of 5, and which was indeed true, because like we wanted to know about what are the values. So 2 is 1, so this is going to be 1, this is going to be 1, and we saw how we got actually divides, because 5 was also divisible and 2 was also divisible. So this is going to be 3 actually. This is no, there's no doubt this is 3, this is 1, this is 2, and this is 1. So at the end, what we need to do here is that uh, once we are done, so we will just map over all the values, this 1, 2, 1, and 3, and we are going to return the summation of all of them. Summation of all of them. So the answer goes on to be 7, and that is our answer. So let's just go on to the code and just code this up, and we'll take hmap equals to default dict, library for default from collections, import default dict. And what we did was like hmap the first element, and we'll assign it as 1, and then we'll go over for I in uh, 1, actually this, yeah, great. So our count goes on to be 1, and that's a dilemma. Do you want to name your variables? Your programmer's dilemma. If I divided by num equal to 0, I modulo num, and by integer division num and hmap, then what we are going to do, we are going to count, and now we will do hmap of, okay, hmap of I, because num was already mapped. So firstly we'll take num and then multiply it with hmap, whatever we was the second condition. Yeah, this was the second condition. And at the end, when we are done doing this, the if condition, we can or just even here we can assign hmap as hmap I as the count. So I just count. Great. Now what else is left? Res equal to 0 for I in h map dot values for val in h, and res is going to add each one of them. You just submit it. Runtime error default date from collection. Okay, default date not type. Covered line plus 7. Yeah, so now let's check again. It's accepted now. So it was because of the mod. So yeah, like that was it. Hope you liked the video. Thank you.